Hi, I'm Edward.
Hi, Cathabell.
I'm Eileen. I'm Erika.
I'm Jonathan. And I'm Dhevans. And here we will talk about magnet and ferromagnetic
We
materials.
hear about magnets a lot. We used to get confused on how they work, although they are very common materials we find every day. This is our lesson of magnets and ferromagnets.
A magnet is a material or object that produces a magnetic field. This magnetic field is invisible, but is responsible for the most notable properties of a magnet. A force that pulls on other ferromagnetic materials, such as iron, and attracts or repels other magnets.
There are two types of magnets, which are natural and artificial. Natural magnets are naturally occurring magnets. All natural magnets are permanent, meaning it cannot lose its magnetism. They can be found in sandy places in some parts of the world. The strongest natural magnet is called lodestone. The other name for lodestone is magnetite. Magnetite is used when compasses are first made a long time
Artificial
ago.
magnets are magnets that are made by us humans. They have stronger magnetic force compared to natural magnets and can be made into many sizes and shapes. There are two types of artificial magnets, permanent and temporary. Permanent magnet are magnet that is made magnetic force never fades. Temporary magnets aren't always magnetic, but their magnetic can always be turned on and off.
Ferromagnetic are those substances which exhibit strong magnetism in the same direction of the field when a magnetic field is applied to it. So, magnetic field is a region around a magnetic material or moving electric charge within which the force of magnetism
The
acts.
behavior of magnets. Magnets can attract or repel other magnets and can attract any magnetic material even if it's not magnetized. When suspended from a thread, a magnet aligns itself in a north to south direction. Non-magnetic materials such as wood, paper, and plastic, and also most metals cannot be magnetized and so can do none of these things. Some, such as paper and water, can let the force of magnetism pass through them, while other materials such as steel sheet do not let the force of magnetism pass through them.
Describing of the magnetic force. At each end of a bar magnet is a place where the magnetic force is stronger than at other places in the magnet. These places where the magnetic force is strongest are called the poles of the magnet. The end of the magnet, which points towards north when the magnet is free to move, is called the north-seeking pole or north pole. At the other end of the magnet is the south-seeking pole or south pole. When the north pole of one magnet is brought close to the south pole of another magnet that is free to move, the south pole moves towards the north pole. Similarly, the north pole is attracted to the south pole. However, two south poles repel each other, as do two north poles. These observations can be summarized by the phrase, different poles attract, similar poles repel. Thank you.
Example of paramagnetic are iron, cobalt, nickel, gadolinium, hysteresis, and more. The properties of paramagnetic are the magnetic force, magnetic lines of force due to applied magnet field are strongly attract toward the material. All ferromagnetic materials become paramagnetic above a temperature called Curie temperature.
So that is it for our video about magnets and ferromagnetic materials, and thank you. We hear about magnets a lot. We used to get confused on how they work, although they are very common things we find every day. This is our lesson of chemistry.
To action.
So that is it for our video about magnets and ferromagnetic materials. Thank you.
Natural magnets are naturally occurring magnets. All natural magnets are permanent. It cannot lose its magnetism.